Hello everyone, this is Tamil Shelby from the Department of Computer Science and Design, SNS College of Engineering. In today's video, we are going to see about two important topics, insertion sort and merge sort. These are the fundamental concepts in computer science, especially when you are learning data structure and algorithm. Let's start with insertion sort. In this sorting algorithm, we divide the given array into two parts. One is sorted and another one unsorted. Then we pick the elements from the unsorted part and insert them into the correct position within the sorted part. The idea is simple, right? Here how it works step by step. First step, take the first value of the unsorted part of the array, and in second step, move the value into the correct place in the sorted part of the array. And in third step, go through the unsorted part of the array again as many as times as there are values. Here is the example which illustrates the insertion sort. Here, this is the first step, initial stage with the elements 12, 11, 13, 5 and 6. In the second pass or second iteration, the element 11 is compared with the sorted array. 11 is the smallest when compared to 12. So we insert the 11 before the value 12. In next step, we compare 13 value. 13 is greater than 11 and 12. So it is in correct order. So there is no need to change the position. In the next step, we take the value 5 and compare to the elements in the sorted array 11, 12 and 13. When compared to these values, 5 is the smallest. So we change the value, that is we inserted the value before 11. So in the sorted array elements becomes 5, 11, 12 and 13. And in the last step, we consider this value 6 and compare to the values in the unsorted array. So 6 is the smallest element when compared to 11 and 12, and it is the greater value when compared to 5. So we place the 6 between 5 and 11. Clear? Here is the Python code for insertion sort. In this example, we take the list of elements 12, 11, 13, 5 and 6 and store the list of values in the variable mylist. And using this mylist, we define the function named as insertion sort. First, we find the length of the array and store the variable in the n. Then we use the for loop to make the looping statements from first to n, and we place the current element to be inserted as key value. Then compare the value, that is move the elements of array 0 to I minus 1 that are greater than the key to the one position ahead of the current position. Then we move the elements of array of 0 to I minus 1 that are greater than the key to one position ahead of the current position. Clear? Then finally, we print the sorted array in the output screen. For example, if our input is 12, 11, 13, 5, 6, the sorted output will be 5, 6, 11, 12, 13. Now let's move on to the merge sort. Unlike insertion sort, merge sort uses the divide and conquer technique. It breaks down the given array into smaller parts and sort them, and finally then merge all the elements back together. Clear? Here's the process. The first step, divide the unsorted array into two subarrays, half the size of the original. Then it continue until it has more than one element. And in third step, it all merge the two subarrays together by always putting the lowest value first. In the final step, it keep merging until there are no subarrays left. This is the example which illustrates the merge sorting. The list of elements 43, 38, 27, 3 and 9 is divided into equal halves, 38 and 27, and in second part 43, 38 and 27. This divide algorithm divide the number of elements as it gone to the single element, and finally it arrange the smallest element at first, then in ascending order. In simple, it arrange the elements in ascending order, and finally it combine or merge the elements together. So finally we get the value as 3, 9, 27, 38 and 43. So here is the Python code for merge sort. We get the input as 3, 7, 6, minus 10, 15, 23, 5, 55 and minus 13 as a list of values, and we store the values in the unsorted array variable. Then using the user-defined function merge sort, we first, if the length of the array is less than 1, it returns the array. If the value is greater than 1, if the list of array is greater than 1, first it divide the array into two half, that is left half and second right half. Okay, the left half contain the elements from the starting to mid element, and in the right side half the element from the middle element to last element are considered in the right half. Clear? Then we perform the merge sort to the left half and also as well as the right half. So here is the function, how the merge sort works. The function keeps dividing the array, and merge function combines them back in order. The traverse through 1 to n minus 1 and index the last element in the sorted subarray, and move the elements of array, that is 0 to I minus 1 that are greater than the key, to the one position ahead of the current position. Example, if our input is 3, 7, 6, minus 10, 15, 23.5, 55 and minus 13, the sorted output will be minus 13, minus 10, 3, 6, 7, 15, 23.5 and 55. So to summarize, insertion sort is simple and works well for smaller data set. Merge sort is efficient for larger data set because of its divide and conquer approach. Here I list some online compiler to run your Python code. You can use Programmix One compiler or online Python compiler. You can use this link to execute your Python code. Thank you.